Hello guys, in this video I am going to tell you how you can determine Thevenin's equivalent circuit and Norton's equivalent circuit for this type of a circuit where you have only the dependent source, right? So, and this problem is question number 39 from the book Engineering Circuit Analysis from Hayt, Kemmerly, Thevenin, right? So how we can determine the Thevenin equivalent circuit for this particular circuit. Now when we talk about the Thevenin equivalent circuit, the two quantities that we need to identify, it is one is RTH, another is VTH. Whereas for the Norton equivalent circuit, the two things that we need to identify, it is IN and it is RN and IN. We know that this RTH and RN are equal. They are exactly equal, means whatever rules that we have studied to determine Thevenin resistance, the same rules, using the same rules we can identify the Norton resistance. Both are equal. Whereas the relation between VTH and IN, it is VTH is equals to IN RN or RTH means this, right? Because Rn is equals to RTH. So it means that if we identify the Thevenin equivalent circuit, automatically we can, using this formula, we can determine the Norton equivalent circuit. Or if we determine the Norton equivalent circuit, then from that we can determine the Thevenin equivalent circuit. So both are equivalent to each other, right? Now let's, over here, for this simple circuit that is given over here, so for this simple circuit we are going to identify both VTH and IN separately, means without using this formula VTH equals to IN RN, right? Now the first thing that you should remember is that if the circuit, this circuit, so if the circuit does not have any independent sources, like this circuit have only one dependent source, right? There is no independent source. So in such cases our VTH, it will be 0 volt, and our IN, it will be 0 ampere, right? So if you if VTH is 0 and if you substitute this value in this equation, so from that also automatically you will come out with IN equals to 0, and vice versa also. Like if you have IN equals to 0 and if you substitute this IN over here, then you will get VTH equals to 0, right? So remember that if our circuit does not have any independent source, then the VTH will be 0 and IN will also be equal to 0. It means the only thing that we need to identify, it is the Thevenin resistance or Norton resistance, right? So how we can identify that? So to identify that, because this circuit does not have any independent voltage source, so what we can do, we can put one test current source, right, of 1 ampere, right? And now in this we will try to identify what is the voltage across this 1 ampere current source, right? So once we identify the voltage, then our RTH will be equals to voltage divided by current. Current is 1 ampere, voltage is V, so at the end RTH will be equal to V. So in this way we will be able to identify the value of RTH. So now if means I just need to find this this particular value of V, right? So let me redraw this circuit. So over here we have this, then we have a resistance, then we have we place 1 ampere current source, right? Now this is 21 ampere ohms, this is 10 Vx. And what is Vx? Vx is this, right? It means Vx is this. So it means that we need to identify this V. This V is equal to Vx, right? So we just need to identify the value of Vx. Now in this circuit, if I apply the nodal analysis, considering this as a node, this as a reference node, right? So if I apply the nodal analysis, then for this current is in opposite direction to this current source. So this current will be minus 10 Vx, right? This current will be plus Va upon 21, and then this current is 1, so plus 1 equal to 0, right? Now over here, what is our Va? Now if you look at this Va, the potential at this node, it will be equal to Va will be equal to Vx. Why? Because Vx, you can see in this particular branch there is no resistance, right? So at this particular point the potential is Vx, right? At this it is 0 volt. So, and since this node and this A terminal, they are just joined by the wire, so it means that terminal A has the potential Vx. So Va is equals to Vx. So substituting this value in this equation, we will get minus 10 Vx plus Vx on 21 is equals to minus 1. So Vx, taking Vx as common, we get 210 minus 210 plus 1 upon 21 equals to minus 1. So our Vx is equals to minus 21 upon this minus 210 plus 1. So it will be minus 209. So our Vx it is 21. This is going to cancel. So Vx is 21 upon 209, right? So substituting, like, so our Vx, it is, let me put it over here, our Vx, it is 209 upon 21 volt. Now we already have identified that our RTH, it is equals to V, right, which is Vx, right? So our RTH, it will be equal to Vx, which is 209 upon 21 ohms. So this is our RTH. This is our RTH. So RTH is 209 upon 21 ohms, which is equal to 0.99 ohms. So since the question says that we need to draw the Thevenin equivalent circuit and Norton equivalent circuit, and we already identified that VTH is equals to 0 and IN is equals to 0. So for this particular circuit, like, we know that Thevenin equivalent circuit is this, where this is RTH equals to 0.99 ohm and this is VTH, over here it is equals to 0 volt, right? So this is our Thevenin equivalent circuit. Thevenin equivalent circuit. Over here, since VTH is equals to 0, so simply we can remove this and we can simply draw this in this form. Similarly, for the Norton, like, we know that the Norton equivalent circuit is represented in this form, right? This is our Rn. Over here, Rn is equals to RTH, which is equals to 0.99 ohms, and this is In, which is equals to 0 ampere, right? And since it is 0 ampere, this is Norton's equivalent circuit. And now since In is equals to 0, and we know that if current is 0, it means it is an open circuit. So simply I can remove this. I can remove this, and our circuit, like, it can be redrawn like this because IN is 0. So this will be our Norton equivalent circuits, and you can see that both this one and this one, they are exactly equal, exactly same. So this is how we can identify the Thevenin equivalent circuit and Norton equivalent circuit for the circuit which consists of only the dependent sources. And just you need to note it down that for this type of circuit where we just have dependent sources, for that VTH will be equal to 0 and IN will be also be equal to 0, right? And only thing that we need to identify, it is the RTH. And remember over here, like, you might be thinking that this dependent source is there, so when it got, like, when there is some voltage over here, then this is going to supply the power. But everything is present, like all these things is already considered in this RTH. So the value there of RTH that we got 0.9, like, it includes the effect of the dependent source also, right? So we do not need to worry, and that is the beauty of this Thevenin equivalent circuit and Norton equivalent circuit, that just by evaluating, by calculating the Thevenin or Norton equivalent circuit, we are just able to reduce the complexity of the circuit, right? So with this, I end this video. If you have any doubt, you can put it in the comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.